everyone, I'm Yingxian.
I'm Joey,
We are currently Year 1 Actual Science students.
and today we are going to talk about indices and logarithms.
Indices and logarithms. What are indices? We have a to the power of n. A is considered as the base and n is the index. For example, 5 to the power of 3. 5 is the base and 3 is the index. There are 5 laws of indices. First, when a to the power of m times a to the power of n will equal to a to the power of m plus n. Next, when a to the power of m divided by a to the power of n will equal to a to the power of m minus n. When a to the power of m with an index of n for the whole indices will then be equal to a to the power of mn. When ab to the power of n, we'll get a to the power of n and b to the power of n. When a over b to the power of n will be a to the power of n divided by b to the power of n. Now we'll be talking about zero index. Zero index occurs when a to the power of 0 or any integer with an index of 0 is equal to 1. But the condition is a cannot equal to 0. Negative index. A to the power of negative n can be written as 1 over a to the power of n. But a is not equal to 0. Fractional index. A to the power of 1 over n is equal to n root of a. But the condition is a and n must be larger than 0. Now let's try some examples. When 64 to the power of 2 over 3, we use fractional index. So we'll get the cube root of 64 squared. Then we'll get the value of 16. For 125 over 8 to the power of negative 2 over 3, we'll then be able to get 5 over 2 to the power of negative 2. So the answer is 4 over 25. Simplify 3 to the power of n minus 3 to the power of n plus 1 plus 3 to the power of n plus 2. We use the first law of indices for the first row, and we'll get 3 to the power of n minus 3 to the power of n times 3 plus 3 to the power of n times 3 squared. After calculating, we'll get 7 times 3 to the power of n.
What are logarithms? For a to the power of x is equal to y can be rewritten as log base a y equal to x, if only a is greater than 0 and not equal to 1. For example, 10 to the power of x equal to y can be rewritten as log base 10 y equal to x. Log base 10 are known as the common logarithms. The base of logarithms can be any positive number except 1. Why base of logarithms cannot be 1? If we have the base of logarithm as 1, we will always obtain x equal to 1 no matter what the number is. This is shown by the example above. However, if x is equal to log base 10 1, we will get x equal to 0. When x equal to log base 1a, we change the base to 10. We will get the denominator is equal to 0. Therefore, x is undefined. Hence, the base of logarithms cannot be 1. Small facts of logarithms. Since a to the power of 1 is equal to a, then log base a is equal to 1. Other than that, since a to the power of 0 is equal to 1, then log base a1 is equal to 0. Lastly, logarithms of 0 and negative numbers are undefined. Now, let's try converting the following index form into logarithmic form. 125 is equal to 5 to the power of 3 is an index form, so we have to change it to a logarithmic form. We will get log base 5 125 equal to 3. Next, we will be converting logarithmic form into index form. For log base 4, 8 is equal to 3 over 2 is in logarithmic form. We will then get 8 equal to 4 power to 3 over 2 in an index form. Laws of logarithms. One of the laws is log base axy is equal to log base ax plus log base ay. Secondly, log base a for x over y is equal to log base ax minus log base ay. Lastly, log base ax to the power of n is equal to n log base ax. You can try out the following question on your own. Let's try to prove that a to the power of log base a is equal to x. Now, we calculate log base 264, we'll be able to derive the value of 6. Now, we calculate log base 9, 3, we'll be able to derive the value of 1 over 2. Express log base ax cubed y to the power of 4 divided by z in terms of log base ax, log base ay, and log base az. Then, we will get 3 log base ax plus 4 log base ay minus log base az. Express log base a square root of x squared y divided by z cubed in terms of log base ax, log base ay, and log base az. Then, through the calculations, we can get log base ax plus 1 over 2 log base ay minus 3 over 2 log base az. Changing the base of logarithms. If we want to change log base a, b to a new base of the logarithm instead of base a or b, we will then have log base cb divided by log base ca. Next, if we want to change log base ab to base b, we will get 1 over log base ba. Remember that the base of logarithms can be any positive number except 1. Using a calculator, we can calculate the values of log base 57 and be able to derive 1.2091. Given that log base 2, 3 is equal to p and log base 2, 5 is equal to q, we are asked to express log base 5, 16, 75 in terms of p and q. After calculating, we will be able to get p plus 2q divided by 4. That's all for today. Please like our video and subscribe to our channel. Thank you!